Very good afternoon to all of you. Today we have 36th distinguished lecture, and it will be given by Professor Partha Chakrabarti, popularly known as PPC, and he is an AI expert, and he will talk about AI. The topic of discussion will be artificial intelligence, emerging face of scientific, industrial, and social revolution, challenges and opportunities. I will just briefly introduce the speaker. Professor Partha Chakrabarti is a faculty member of the Department of Computer Science and Engineering at IIT Kharagpur. For more than 35 years, he completed his BTech and immediately started his PhD from the same institute. He was the director of IIT Kharagpur from 2013 to 2019. And before that, he was Dean of Sponsored Research and Industrial Consultancy for 10 long years. He has published more than 300 papers and supervised more than 2 dozen PhDs. He has carried out large projects for industry, government, and national missions. Professor Chakrabarti is a highly decorated person. He is a fellow of Indian National Academy of Engineering, INSA, and Indian Academy of Science, Bangalore. He is the recipient of prestigious Shanti Swarup Bhatnagar Prize, Swarna Jayanti Prize, Swarna Jayanti Fellowship rather. Then President of India, gold medalist based on his BTech performance. He was topper. JC National Fellowship, Young Scientist in Engineers Award, and many more. The abstract of the talk is all circulated to you. You can really see that one. And possibly we'll have one of the very, very illuminating lecture by PPC. Okay. Please start it.
Thank you, sir. Thank you. First of all, I would like to thank Professor Damodar Acharya, our teacher and our mentor for many, many years. And thank him. It's a privilege and honor for me to be present before you online for presenting a lecture on the most hottest topic of the day today, which is artificial intelligence. By God's grace, that has been the topic that I have done my research on from the beginning of my PhD onwards. So I have had my journey across this subject over the last 35 to 40 years. I will share my screen and try to give you a brief overview of what is artificial intelligence and machine learning, how it works, what are the mechanisms by which it is affecting us, how it has become a new paradigm for almost everything that scientific science and technology people do today, and what are its pitfalls and how we can use it and leverage it in the ambit of science and technology, in the ambit of the social revolution that is happening for all of us. I will share my screen and then present my slides. Is my screen visible to all of you?
It is visible, but can you make it full screen, please?
I have made it full screen only.
Okay.
Anyway, this is all right.
So
you're able to see, read also.
Yeah. So let me see if I can do something better.
No, it's okay. It's all right. You can go ahead. Yeah.
Right. So the topic of today's lecture is artificial intelligence, emerging phase of the scientific, industrial revolution and social revolution, and the challenges and opportunities for India. One. So if we look at the scientific and technological landscape, we see that most of the science and technology have come in these 6 phases. First is people have made observations, whether it's an observation of a natural observation or an observation of an engineered phenomenon. And from these observations, new knowledge to new knowledge has come. From new knowledge, people try to develop theory, whether it's a physics theory, a chemistry theory, or a biology theory, or an equation, or a mathematical model. From there, we move on to engineered applications. That means they move on to engineering and technology development. And finally, it comes to deployment at scale. For example, the mobile phone that we have today with almost all of us is deployed at scale. And around all this, we have incremental improvements of technology. For example, the fountain pen that we all use, or the ballpoint pen that we all use, or the pen that we all use, if we look at its history, it has had a development of about 1400 years in just the fountain pen with the ink and its scientific evolution. And if we look at past history, then writing has about 5,000 years of history. So this has created knowledge levels, intellectual property, trade secrets, and know-how, and systems and subjects developed over a period of time. Initially, we had the natural sciences, then mathematics. Then they broke down into physical, chemical, and biological sciences. Then came engineering, economics. And then came the dramatic change of the 20th century, the 70s and the 80s, 60s, 70s, 80s. Then came computing and the electrical sciences. And then in the latest era, we have artificial intelligence and cyber physical systems. Computing has had the most important effect on science and technology. Almost every subject that we know has a computing counterpart, whether you look at it as computational physics, computational biology, computational chemistry, computational social sciences, computational humanities, computational economics, digital humanities. Every subject has had a computational counterpart, and computation has now even renamed a large number of subjects. For example, subjects like decision sciences, computational biology, and so on and so forth. And computer sciences, you have algorithms, models, networks, etc., etc. Computing came out by people or human beings writing programs and making these programs follow scientific principles. Then we moved on from computation to what is called artificial intelligence. Artificial intelligence came around at the same time when computation came. And this was also proposed by the same person who proposed the fundamental model of computing, that is Professor Alan M. Turing. Along with the fundamental model of computing, which is called the Turing machine, Alan Turing proposed this question in a paper saying, I propose to consider the question, can machines think? That means, can machines become automated? Can machines automate everything that is possible? While the Industrial Revolution started the concept of automation, we started to believe that automation was driven by human intellect. But Alan and Turing seeded the idea that can machines be made intelligent. During that time, a test was derived. It was called the Turing test. It said that if a human being is sitting interacting with something else, on the other side, the human being has got something and is interacting on a computer and interacting with somebody else on the other side. And if the human being cannot make out whether that other side is a computer or a human, then that other side, if it is a computer, then it is said to be intelligent. So a computer would deserve to be called intelligent if it could deceive a human being into believing that it was human. And as you can see with all the technologies that we are using today, we have almost reached a significant number of steps in that direction. So automated problem solving. Automated problem solving is at the heart and the origin of artificial intelligence. Starting with Newell and Simon, it said that instead of solving every problem individually, that means writing a computer program or a mathematical model or a decision science model or a formula for solving individual problems, can I have a meta method or a meta algorithm or a meta process by which, given any problem that I have, I will be able to solve it? It is like this. It says that I have, like we have problems in our exams, you are given a problem statement, solve it. Whether it's a chemistry problem, biology problem, physics problem, mechanics problem, a mixed problem, a research problem. So can I have a meta method or a method which takes the problem description as input and produces the solution as output? I have given 6 examples here. For example, the Google pathfinding problem. Suppose I want to solve the Google pathfinding problem. Normally, I would write one algorithm. I want to write a chess playing program. I want to write another algorithm. I want to have a code for writing robot assembly. I want to write one algorithm. I want to design the layout of a VLSI design chip. I want to write another algorithm. Or a timetable scheduling, or even if I want to solve a integration problem symbolically, or I want to do an algebraic simplification. The question is, automated problem solving attempted to find a single methodology which would solve all problems. So here, the problem description is the input and the solution algorithm is the output. Over a period of time, this is the model that I have evolved about artificial intelligence. Artificial intelligence has got 3 major paradigms. Artificial intelligence has got a representation. For every problem, it tries to find a general purpose representation. The second is, given a representation and a problem to solve, it tries to find a meta algorithm which will solve that problem. And the third thing, which is the most important thing that artificial intelligence evolved over a period of time, is learning, which means that as I am solving one problem, the more number of times I am given to solve a problem, the better and better and better I become. So the 3 legs of artificial intelligence concern representation or model, reasoning or meta algorithm to solve the problem, and learning to be able to solve the problem better and better with time. Normally, from all our ideas, our methods for doing all these 3 were algorithmic or symbolic. But over a period of time, artificial intelligence developed 2 more methods. One, so we used to have an algorithmic representation and algorithms for solving and algorithms for learning. Then came the whole of statistics, and then we started having statistical methods for representation, statistical methods for solving, and statistical methods for learning. These statistical methods came to be known today as the popular method. It is called data science. So it is called data science methods. The third and the most interesting and the most potent method of today to solve very complex problems was borrowed from the idea of the human brain. So other than having an algorithmic model or a statistical model, people developed artificial models to resemble the structure of the computing structure of a human brain, and therefore we began to have connectionist or neural models. So this 3 into 3, this star of AI, as I call it, has got these 3 paradigms of problem solving and the 3 methods like symbolic, statistical, and neural. The diagram on the right is a very interesting diagram of AI. It says that initially, given the AI problem, the human being would find the solution to the problem. So this human being finding the solution to the problem, then it would say that no, human being will not find the solution. Human being will identify model to solve the problem. That means we will have one meta algorithm, and this meta algorithm will solve any problem. Then it came that the meta algorithm requires a problem definition. So the next part came that even the problem need not be defined. We will look at the input-output pattern of various available solutions to the problem and then try to extract features from the problem, and then this would become automated. So first, human beings were finding the direct solution. Then human beings were developing a meta algorithm and automating the solution finding. Now human beings were finding features, and from the features, automatically the meta algorithm and the actual solution would be found. For example, people are looking at various various intonations of speech, and then trying to determine whether it is a male or a female. So having some data like that and extracting some voice and intonation features, we try to detect whether it's a male or a female. Finally, we come to a stage where these features also are not identified by humans, and these features are also automatically extracted. So you only have a set of data. So the first method, this was computing. This was called classical AI. This was called machine learning, and this is called deep learning. One more, so this whole of AI is founded on mathematical, statistical, algorithmic, and connectionist approaches. It is able to assimilate heterogeneous information, do automatic discovery, and have customized and synthesized explanations. One more target remains, and which will come up maybe in another 10-15 years, which will be the whole of the quantum methodologies, which will soon get integrated into the whole of paradigm of AI. Already quantum machine learning has come, but more of it will be coming out. So as I just said, artificial intelligence is the overall name given to this method, which tries to automate the process of thinking, problem solving, reasoning, and learning. Machine learning is a subset of artificial intelligence, and this machine learning, which is a subset of artificial intelligence, is a methodology which uses data, human-generated statistical features, and various other features to solve the problem automatically. And deep learning is a subset of machine learning, that uses neural network architectures. On the right side, I have listed out artificial intelligence. During my undergraduate days, Professor Acharya will remember, they were all the persons who developed the subjects and other things when we were students. That was one subject. Today, it has not only become one subject, it has become an undergraduate degree, a postgraduate degree, as well as a transdisciplinary and interdisciplinary degree. And therefore, there are various concepts, and I will briefly rush through these concepts. The fundamental idea of artificial intelligence, the base of artificial intelligence, is founded on the notion of exploration. I would like to search for a problem. This search is a fundamental method in optimization. It is a fundamental method in decision sciences and various other, including control theory and others. The state spaces, and solutions are a general field in many disciplines of science and technology. However, artificial intelligence tries to combine all of them together into search. The second aspect of artificial intelligence is knowledge. It says search is a mechanism by which you will explore various alternatives to find the solution. And knowledge, the more knowledge you have, the less you have to search. And this is just not an English language statement. This is quantified by several theorems and other things, which I am not going to go into. But whether it's a control problem, whether it's a puzzle problem, whether it's a robot problem, whether it's a automated robot game playing problem, all of this is founded on this search paradigm. At the end, all of AI, through the various layers that it goes through, ends up in various forms of search. So search is the fundamental baseline of artificial intelligence. The second foundation of artificial intelligence comes from logic. We formalize logic into a form where the ancient form of logic, which was there in India, China, Arabia, and then finally in Europe. Whereas, for example, if you look at the bottom example here, the statement says, wherever Mary goes, so does the lamb. Mary goes to school, and I can conclude the lamb goes to school. It looks obvious, but I've just shown a very simple example here. And this is how you can code it in logic. You can say for all x goes Mary x implies goes lamb x. The second fact is goes Mary to school. And what I want to derive is the lamb goes to school. And you can show that this can be proved by a general method, which means that I can take any problem statement that I have, and this logic is a meta method which will code any problem statement that I have in any subject, in any domain, like I mentioned earlier, and will automatically find the solution. The second example says, no contractors are dependable. Some engineers are contractors. Therefore, some engineers are not dependable. This is just an example that I have shown here, but you can make, there have been cases where there are thousands and millions of such formula. And with the huge power of computing, we are able to solve these logically. So logic forms the second paradigm. The third paradigm is constraint satisfaction. Normally, we say a single variable takes a value, but AI says a variable is defined by a set of constraints. And interactions between variables ends up in a methodology called constraint satisfaction. And it can be used to solve a wide variety of problems. I can see Professor Dikshitalu there, and I am very much aware that he was very much responsible for solving a large number of vision problems. And all these problems used to be solved by this generic method of constraint satisfaction. So I was referring to you, Professor Dikshitalu, about these constraint satisfaction methods, which you used very widely in your vision problems. Now, in the real world, perfect knowledge is not available. Knowledge is available only in incomplete, noisy, and imperfect. In such a situation, when people have to take decisions, these decisions naturally will be approximately correct. So the whole of reasoning was now based not on exact values, but on probabilistic values. And therefore, this is an example of how we make decision under uncertainty. The previous three methods that I talked about were methods which are the base methods which assume certainty and completeness of information. But when you have incompleteness of information, for example, in this case, there are 5 nodes. Whether there is a burglary has happened, an earthquake has happened, an alarm takes place, and if an alarm takes place, then whether John calls the police or Mary calls the police. And as you can see that there are certain probabilities associated with each event. And then if you want to know what is the probability that there has been an alarm and Mary does not call the police, then you will find out the probability of all that. So they now moved over from absolute certain information to more accurate real world situations. Language. Language as it is, has been at the heart and the holy grail of artificial intelligence. For example, I am talking to you, all of you. You all can hear me. Hearing me, you all are able to understand something. And then there will be a dialogue or interaction between people. All of our teaching learning process that we have developed in academic institutions is sourced on the fact that language is the fundamental mechanism to express problems, to express solutions, and to transfer learning. And language has got so many aspects. And even today, though it is very, very advanced now, language understanding through the methods of modern AI, but language understanding involves phonetics or phonology, morphology, syntax, semantics, and pragmatics. Pragmatics, for example, if I say that I have to go to the bank, which is on the bank of the river Damodar, then these two banks, though they are the same word, they mean different things. All of us talk ambiguously, but even in this ambiguousness, we are able to express our. So language understanding form the fundamental paradigm of problems of what AI needs to target. And today, as you can see, much of AI and the modern AI has reached this high level of expertise of both visual understanding, language understanding, speech understanding. It is stuck a little bit on mathematical processing, but the rest of it, it has really overpowered human ability. And I will come to that. Then we come to machine learning. What does machine learning do? Machine learning takes data and tries to make sense out of data. So machine learning, for example, as I just mentioned, it will take pictures of people and try to identify who is it. It will take fingerprints of people and try to identify whose fingerprint it is. Now, there are three parts of machine learning today. One is supervised, which means that I have some training data which has got input and output. For example, I have got pictures and I can tell that these are pictures of cats, these are pictures of dogs, these are pictures of flowers, and so on and so forth. So I have got some data which has got the input and the correct output. And using this, I do a training. And by this training, when I get an unknown piece of data with input only, I need to predict the output. So this sort of training, when I have got data, some sample data, which has got both input and output, and I train that data, it is called supervised learning. The other is I have got data, but I have got no ground truth of the data. That means I have got pictures. Now from the pictures, I should be able to figure out just by looking at the pictures whether this is a male or a female, whether there are certain kinds of classes of people. On I have pictures of lot of animals, automatically I should figure out, separate out the cats, the dogs, and the horses and the elephants. So this sort of unsupervised learning is used by methods called clustering, whereas supervised learning uses the traditional statistical methods of regression, interpolation, and classification. And I have listed out various methods that are there. Much of these are borrowed from statistics and decision sciences. The third is an interesting form of learning which came out of artificial intelligence. I'll give you an example. Suppose a robot is trying to find a path through a maze, and then once it is going and it hits a wall, then it knows that this coming closer to the wall is not a good idea because hitting a wall gives it a penalty. Reaching a goal gives it a reward. We will all remember that when we were all children, we used to put our fingers into plug or fire or something. And once we got a feedback from it that it is a bad thing for us, we learned that this is not to be done. Or when we got a gift, when many of the children you will see that whenever they see somebody, they start crying, thinking that they will get sympathy from them. So all this comes from this huge methodology called reinforcement learning. And reinforcement learning is of various kinds. So there are three methods of machine learning: supervised, unsupervised, and reinforced. Finally, we come to neural networks. As I said, we have symbolic or algorithmic methods, we have statistical or data science methods, and finally, we try to copy structures based on the human brain. So artificial neural networks are models which are inspired by the human brain, and they contain two major elements: nodes, which are called neurons, and connections, which are trying to replicate the axons or the connections or the dendrons of a neural. And I have drawn up these four basic architectures. And each of these neuronal elements is a nonlinear element. This nonlinear element follows many such structures. One of the famous structures is the sigmoid function that it follows. It is a continuous differentiable function. And because of this, it is very useful and analyzable. The first one is called a feed-forward network. This has got no cycles. It has an input, a set of intermediate node neurons, and an output set of neurons. It has got no cycles, and there is a standard theorem which shows that any function up to any level of accuracy can be obtained or can be modeled by such a feed-forward neural network. It is to be a straightforward combinatorial function, but it can be modeled up to any level of accuracy by a neural network. And this is the fundamental neural network called the feed-forward network. The second fundamental neural network is when everybody is connected to everybody. This is called a fully connected or a Hopfield network. This has got very interesting properties because unlike a feed-forward network, which has got inputs and it propagates to the outputs, here everybody connects with everybody, forming a dynamical system. And this dynamical system settles down into some minimum energy or minimum stable forms. And using these Hopfield or connected networks, it can be shown that memory can be modeled. For example, we remember that if you see half the picture of Gandhiji, you know that this is Gandhiji. You know from partial picture, you know what the rest of it is. So this is sort of associative memory, which is a fundamental element of a human cognition, and that can be modeled by this connectionist of field networks. A combination of feed-forward networks and fully connected networks in a partial form, that means part of this is fully connected and part of this has feedback, is called recurrent neural networks, and we shall see that these recurrent neural networks are able to model various things including speech, language, and forms the heart of many of the modern AI techniques that we see today. Finally, there is another architecture which is called the competitive neural networks, where the output neurons compete with each other into a winner take all or something else. And these form very interesting neuronal maps, whether it is the map of how the eye decides on a particular object. And there are various details on how these Cohonen maps or winner take all networks work. So in summary, we have artificial neural networks of 4 broad categories. Now we come to deep learning. Machine learning, as we said, takes an input, features are extracted, and then the neural network produces the output. For example, you have a faces or you have fingerprints. And from this, you extract features. For every fingerprint, all of those who have worked on fingerprints will know that you have various kinds of features. Or you take an image of an animal, you know that there is an eye, nose, etc., etc. But an animal would have 4 feet typically, whereas a human being will have 2. So the features were extracted by human beings, and the machine did the classification. Deep learning was formed out of having a deeper neural network where the features were also automatically identified by the machine. So the input-output framework was completely machine-driven. Among the deep learning frameworks, the problem with neural networks in any of these neural network architectures is that the number of parameters is extremely high. And the problem of learning, to learn anything, you need millions and billions of examples so as to be able to correctly learn these parameters. But in certain domains, people came up with easier and newer architectures. For example, in the vision recognition problem, or a 2D or 3D visual imagery problem, you will see a famous network called the CNN, or the Convolution Deep Learning Networks. And this has got a certain architecture, which I will not go into much details. But these convolution or deep learning architectures are the best architectures today. So today, whether it is handwriting recognition, whether it is image recognition, whether it is trying to find out moods, trying to find out the emotional expression of a person, when you look at a person who is in the class and you're automatically looking at an online lecture and you want to figure out who is engaged, who is concentrating, who is distracted, all of these things can be found out from visual imagery. It is used quite a bit in many of these countries to actually identify people, track people. It is used, and in many cases, it is banned, such privacy. It affects privacy. But machine learning on imagery has reached such a sophistication that today it is able to look at X-rays and give you outcomes of X-rays better than most expert doctors. It is able to look at echocardiograms and give you output which is better than most doctors. So even in the area of medical diagnosis, it has become such that during the COVID era, when we look, people would just put out their X-rays, and automatically on the cloud, we would be able to determine whether this person has deep COVID, whether this person could have COVID, whether this person is free, etc., etc. Even from voice, and I will come to the next example there. Another architecture, which I will not go into details, is called the long short-term memory. So Professor Vasudev, I'll answer your questions at the end, whether AI can surpass humans or not. I understand those questions. We will have it in the discussion session, and we can have a discussion on those topics. But I want to, because this is the INA community, I want to go through more details. Professor Acharya, you can tell me whether I should, if this level is all right, or whether I should just go, whether this sort of, let me give the landscape of the whole thing, then it will become clear. So this tries to measure a long short-term memory architecture, and this is one of the foundational architectures for speech recognition. It is also the foundational architecture for, you have this autocomplete that you see. When you're in your phone, you will see the next word is predicted. And the more you use your phone, the more you try to type in something, it starts predicting the next word. So this next word prediction or speech recognition, all of this are founded on this long short-term memory architecture. Knowledge representation and databases. Today, databases consist of billions and trillions of nodes. How do we store all of this? How do we access all of this? And how do we combine to form combinations out of this? So moving way out of standard relational databases, knowledge representation and knowledge databases and their linkages forms a very, very deep part of most of the industrial paradigms. So what is AI, ML, and big data doing? It is transforming domains because modeling, prediction, diagnosis, monitoring, and decision making all becomes automated. The second is that it is able to transform heterogeneous data into insights and knowledge. Third, all the complex nonlinear processes for which functional forms were not there are all more accurately modeled using the modern AI techniques today. It can give a descriptive analysis of the situation, a predictive analysis of the situation, a preventive analysis of the situation, and a prescriptive analysis of the situation. Whether it is a health related, whether it is cyber forensic related, whether it is with police, or whether it is with analyzing student behavior, all of this, automatic methods of describing the situation, predicting what will happen. For example, we have used it to predict what is the grade the student will get, to predict whether the student will drop off this subject or not. The third is prevention. How to prevent crime, how to prevent cyber fraud. Most of you will see nowadays that in many cases, when you are working with the bank, if you try to make 2 or 3 transactions, one after another, immediately your card is locked. And those banks which do not do that are actually not following any of these AI analytics at all. It is able to discover patterns from data, text, and signals. And I will show you how these architectures work in very, very complex domains where we have worked with them. It is able to learn and reason without writing any program. So nobody needs to write any program anymore. As you have seen, NVIDIA chairman said programming need not be studied at all. Risk prevention, safety improvement, and deeper than humanly analyzable results in many, many scenarios. Not in all, but in many scenarios. And assimilation of human experts and human knowledge, replacing and enabling sustainable solutions. But AI is not always hunky-dory. AI has got many, many complicated and difficult aspects, which we shall quickly and briefly address. So what are the conquests? There have been many, many conquests of AI. If you look at this picture, can anybody tell me who is this person with his hand on his face? Does anybody know? This is the first time Garry Kasparov lost to a computer. So this was the first time the world champion, lost to a computer. And today, computers are the best chess players. Human chess players are hardly able to beat computers. The second is natural language interaction. Today, you have interaction which is going on, and the computer today, all of you who are using Chat GPT or any of the variations of those chatbots are able to see that while it does make mistakes, but it is becoming better and better. Many of you have interacted with crude versions of robo-citizens. Integrating AR, VR, and digital twins, one is able to come to actual mechanisms of how machines work in a digital platform. That means digital twins are able to digitally recreate physical objects, which means that they can do a deeper sense of what if analysis and come to prediction, uh, diagnosis, monitoring, and things like that. This is the Mars rover. As you can see, this is a simple device. It takes about a few minutes to communicate from Earth to Mars. And therefore, unless you have an autonomous device, this was just the rover. And if you realize in the US, they built a helicopter. And helicopter which learns to move around in Mars is unbelievable because their gravity, their everything else is different. And how does it learn to do everything else there is a very interesting phenomenon. Today, robotic surgery has become more and more perfected, and therefore robotic surgery. So I've come to a few of these examples. And what are the three things that has made AI powerful? It is not just the AI methods and algorithms. Alone, these methods and algorithms will not be able to circumvent. So the first thing that has happened is that compute has become free. That means on our mobile phones, we have the power of compute of doing mega multi-flops. Many of our, for example, the desktop computer, the laptop that I'm using to display and give this presentation has GPU in it. It can do AI with utmost ease. The second is when storage is free. All of us have terabytes of storage on our systems. The third is when communication becomes free. Today, all of us are working in an almost, seamless fashion, interacting and hearing this lecture. And very soon that we will be able to have almost telepresence. There is telepresence is already there, but with more freedom of bandwidth of communication, we're going to have telepresence and much more. So the whole social interaction, the digital interaction will become completely different. And AI is going to completely transform the way in which we are seeing things. The biggest bottleneck for us is energy and power. And that is where I think AI is suffering. Most of the AI tools are power guzzlers. They require atomic power plants to learn. And therefore, that is a big problem that we face. Today's AI comes from this whole new concept called large language models or large models. So what are these large models? To briefly elaborate on these large models, the large models or the deep learning architectures consist of two parts. One is the predictive architecture, the other is the generative architecture. The predictive architecture looks something like this. The predictive architecture looks something like this. It takes a picture or a speech or a photo or a video and then tries to predict. For example, from this picture, it tries to predict that the age of this person, the action that this person is trying to do, the gender of this person, and then it tries to make where is this person going, which direction this person is going, moving forward or backward, and etc. etc. So one part of AI which I talked about a little earlier is predictive AI. And having learned this predictive AI, the orange part that is there is called the model or the latent representation of the system. This latent representations of the system succinctly encodes how much of the information is necessary for the task at hand. The second part, so this is also called the encoder. This is also called the encoder architecture. The second part is the generator or the decoder architecture. It takes a representation and then you say, give me a picture of a 50-year-old smiling woman. It will generate the picture for you. You will say that this is the sentence I want to write an emotional poetry on nature in the style of William Wordsworth. So it will write a new poem, or you can give a piece of text and say, convert it into poetry in the style of William Wordsworth. Or you can say, write a 30-word essay on the topic of disarmament. So it will, this is the generative or the decoder network, which takes the latent representation and takes what is called a prompt and then tries to generate the output. So it will now, previously you were giving it a song and it was saying that this is a song of Manna De, or this is a Lata Mangeshkar song. Now you will say, reproduce a Lata Mangeshkar song of this lyrics. So this is the generative part of the AI, and therefore the encoder, the latent representation, and the decoder together form this generative AI, the combined model, which is the most popular model today, which is the model that we see overall in ChatGPT and various other frameworks. So now comes the most important thing, is called the foundation model. What does the foundation model do? The foundation model approximately takes in all the knowledge that is available with us, whether it is data, text, image, speech, signals, whatever, and trains it into a single model. So today, GPT-4 has got some 4 trillion parameters. 4 trillion parameters. The number of people in this world is 8 billion. The parameters there is 4 trillion. So this whole concept of generating pre-trained foundation models. So they will give you a full model of image recognition. Now what you want to do is you want to fine tune it. You say, I have got specific data of agriculture pictures, images of agriculture where there are plant diseases in my area of Odisha or Maharashtra or Andhra Pradesh or whatever. And with these small pictures, with these pictures of this domain, instead of training a full model, I used a partially trained model, which was computationally expensive. And then I fine tune it with the data that I have. And I'm going to get a very, very accurate model myself, which means that if I use a pre-trained model or a foundation model and I fine tune it, then I will be able to generate a new model, which is more powerful than if I tried to do the whole training myself, which would be very expensive, time consuming, and I wouldn't be able to have sufficient data. From this fine tuning, people came to the structure of what is called a prompt. A prompt is a question which gives the context and a query. For example, if in a chat GPT, you may give a query only. Or you may say that here are 3 kinds of answers given by students. And for this problem, try to write the answer in this style. So we come to this whole concept of prompt engineering, which is the fundamental model today. If anybody needs, I can go into the details of all of this. And this is the foundation of what is evolving into what is ChatGPT. But as we all know that AI produces results which are not human-like. So the final outcome of pre-training followed by fine-tuning followed by a human feedback. It is called RLHF, reinforced learning with human feedback. So they take a lot of human feedback. And as you can see, ChatGPT and all these models that we see today, they have taken a large amount of human feedback so as to be able to make these behave and respond as if a human being will understand it. So let me come to some glimpses of modern AI ML in action. In 2019, the first AI generated textbook on lithium ion batteries, it was a machine generated summary of current research. And at that point of time, this book, which was written fully by AI,
I tell you, placement saying that.
Professor Murthy, if you can kindly mute yourself. SS Murthy Sahab, can you kindly mute? So the first AI generated book, this was at that point in time the most authoritative book on AI, on lithium ion batteries, and fully written by AI. I'll give you another example. In 2019, what people did was they took all papers written up to 2009 on thermoelectric materials and gave it to AI. And this AI did not have any prior knowledge of thermoelectric materials. It just read text papers. And by a mechanism called word to vec and creating a very, very high dimensional space, understanding relationships between them, it predicted what are the next 5 next level materials for thermoelectric work. So using just an algorithm called word to vectors, it produced 5 of them. And out of these 5, so let me repeat, up to 2, it read papers up to 2009 and predicted the next 5 materials by using AI. And the top 5 materials, the best material of them was actually done by humans in 2012, which means that 3 years it took human beings to develop that material. But AI, with its complete knowledge, was able to do that within a couple of days. Today, you give us, you give a set of documents and it will make a PowerPoint presentation for you. Directly convert it into PowerPoint presentations and give it to you for your class. These are all available now. Somebody drew a block diagram and taught in the class, and from there it developed the code of that whole mechanism. It just drew a block diagram and explained the methods, and the full code was produced. AI used similar word to vec technique called atoms to vec, and it read in all reactions of various functions, and using all the atomic numbers and the reactions and all of that, it was asked to present the relationship between these elements. The names of the elements were just encoded as A, B, C, D, E, F, G, H, and it was asked to present these elements in a tabular form in such a way that they are close to each other in that table. The ones which are more related are next to each other. And believe me or you, that this vector dimension by which they produced it was almost identical to the periodic table. So these are all works which have shown that AI has got enormous power to assist and discover. By running about 10,000 training reactions, AI is able to predict the type of reaction without actually running the reaction up to 97% accuracy. Today, very recently, a new AI tool has come which is able to predict the function of enzymes based on their amino acid sequences. Even when the enzymes are unstudied or poorly understood. A new tool dubbed Clean outperforms the leading state-of-the-art human-developed tools in accuracy, reliability, sensitivity, and gives a much better understanding. So just like ChatGPT uses data from written language to create predictive tests, they are using the language of proteins. There is a language, the mechanism is SMILE and things like that. So there are certain formats by which they are able to predict the structure of proteins. You are aware of this AlphaFold product that has also come out. In simple engineering tasks, whether it is how much fuel a car should predict, how much fuel should be done drop by drop in an engine of a car, how much an inkjet printer should print, and so on and so forth. AI is now ubiquitous everywhere. In the electron microscope era, identifying defects which human beings are used to look at it in deep ways, I talked about identifying structures in X-rays which miss even an expert doctor's eye. I'm happy to note that one of my own BTech and PhD students has started a very interesting digital pathology and microscopy tool by using simple cameras and AI, and he runs a startup today in India which has brought down the cost of digital pathology compared to the tools of companies, large companies, by at 1/10 of the cost, giving them the same or better accuracy. Our work has also been able to do detection of dementia. So you take these brain MRI images, and from these brain MRI images, we have a very accurate method to detect dementia. We recently produced a new LSTM form or encoder-decoder architecture to predict progression of dementia. That means you have come for the first time. How far will dementia progress for you? And the more number of visits you make, we have been able to show that our prediction becomes better and better and more accurate. Coming to engineering, in the real-time monitoring of machining tools, whether it's prediction of outputs of roughness, material removal rate, whether it is real-time control of robots in loading and unloading, whether it's the health monitoring of machines. On the welding side, whether there has been a weld defect, whether the welding parameters are to be done accurately or not, the weld seam tracking. I'm showing you all this because some of these have already been done by my colleagues in our advanced manufacturing center. And collaborative welding, virtual welding, it's a very interesting thing when the human's hand is also controlled by the robot to do exactly the welding. It's a very interesting mechanism. In additive manufacturing, where automatic 3D printing workflow or 3D printing process and how we can do defect analysis, all of this has got integrated use of AI. So AI has become the hallmark of intelligent machines, some of which are integrated in our own bodies. The largest requirement of AI chips is in motor cars nowadays. The better the car, the more AI it has got integrated, whether it is in atomic reactors, whether it is in which are embedded in your bodies, or whether it is in the complex control systems. These lead to what is called cyber physical systems and Internet of Things, industrial Internet of Things. So this has got a physical world. From the physical world, a digital twin or data is acquired, and the whole of that data is used for taking intelligent decisions. I will give you an example architecture. There are many such. For example, the agricultural cyber physical system has got three major layers. The bottom layer is the physical layer where there are machines, there are people, and there are robots. And each of them have devices which collects data and which operates on these. Then there are these edge layer decision makers, and each of these edge layer decision makers control a set of these devices. This two-way control and two-way real-time control has got the following features. They extract data that is coming out of the physical layer devices, and they give control and advice to these physical layer devices exactly on how to actuate and how to work. From these edge layer devices, this goes to the back end of the cloud, where all the data is collated together, and backstage offline machine learning algorithms work overnight or maybe at the back end, so that by the next day, next week, next month, all that is propagated then back from the upper layer to the edge layer to the physical layer. So this is a three-layer architecture. There are 4 or 5-layer architectures as well. Robotics. Modern robotics, which are integrated with AI, have got very, very powerful control systems, whether it's a pick and place robot, whether it's a packaging robot, whether it's a gluing robot, whether it's a machine tending robot, and things like that. In the era of COVID, there were many of these robots which are used, which were providing assistance to people. They were providing food, they were providing injections, they were able to come and take your tests and things like that. Finally, digital twins, as I just mentioned. Digital twins observe and collect data from the sensors and try to create a visual and as well as a simulation model, as well as a machine learning backend, which can completely control the physical devices. In addition to that, extended reality, where people are now taking the headset on their eyes, and recently you must have seen a very interesting video on the social media where our famous actor Amitabh Bachchan ji was using such a video and getting an interaction. So it fully embeds the physical world with the virtual world, and you can simultaneously interact with them, which means that you're seeing a machine, and on your screen, which is on your headset, you're also seeing exactly how the internals of that machine is working. You can control that machine just using your fingers, gestures, and eye control. I come to a very interesting development which came out at IIT Kharagpur from the group of Professor Suman Chakrabarti and Arindam and others, where what they did was they took a lot of data of COVID infected elements, used digital microfluidics to try and study from this. They did this reverse transcription loop mediated isothermal amplification followed by paper-based microfluidics, and collected, as you can see from here, from the average features, they collected automatically from data certain color space transforms, and from that they had experimental data. Finally, when they put all this onto a mobile phone, and all you needed to do was to get some pictures, and from those pictures you are able to predict. And I think this was a very, very important technology transfer that happened recently. Another work that happened during COVID was this IoT-based AI/ML for respiratory health monitoring. Just from the speech of a person, they were able to detect whether this person is infected or not. Then, other than the speech, the masks were designed using certain kinds of sensors, which were able to. So these masks were not just simple cloth masks or something. they had something else associated with them. In addition, they had some devices on their chests which were monitoring the heart, and so on and so forth. And this whole paradigm was a very interesting paradigm through which people were able to do this sort of respiratory health monitoring. With this, I come to the next phase of cyber physical systems integrated with what is called cognitive AI. Cognitive AI, in my opinion, has got 3 steps. First is the human assist. For example, I have a camera, or I have my spectacles with a camera. It assists the human. It flags that this is a problem area. For example, this car is speeding very fast, or this person seems to be known to be somebody else. But the decision is taken by the human being. The second is human as a system. That means certain base level decisions are taken by the machine, but more critical decisions are taken by the human being. And the third is system as human, that the system behaves like a human being. We have already reached very powerful steps in the first two, and the third is where we are all deeply afraid of what is in store for us. So whether it is language recognition, speech recognition, voice recognition, spoofing attack, emotion recognition, all of this has become now part and parcel of things. For example, behaviometrics is a new field which was there in psychology. But today, from facial analysis, micro expressions, thermal images, I used to, we developed a new technique which was very interesting. When everybody was in COVID, all of us were wearing masks. So how do you recognize a person now? So I figured out that now we recognize a person from their walking style, because the face is fully covered. So you can only get a silhouette of that person, maybe a little bit of the height, etc., but from the walking style. So once you suppress one of the sets of features, you immediately have another set of features. So today, trying to detect behavior metrics through AI using both language, speech, emotion, as well as textual interactions. And there's a very interesting body of work which tries to do this psychological analysis based on this sort of behavior metrics. It is also used by the AI cameras which work in rail stations and other places, where they try to figure out this person is a little abnormal. So this is called anomaly detection. So they try to detect anomaly situations automatically, which would skip the human eye. Finally, there is a different direction. People are now trying to design a computational brain, either using the GAI or the general AI approach, or the computational neuroscience approach, or using artificial neural networks. And this sort of brain-computer interaction, which we are doing a lot of work, many people are using eye trackers, skin measurements and things like that, EEGs. Very interestingly, we were trying to use EEGs to improve. We just have a recent paper where we are using EEGs to detect defects. So, how does even the human being does not know, but inherently their EEG tracker uh, gives them certain signals which many people are unaware of. So the latest in that scenario has been a new mechanism by which a person who was completely ill, based on fMRI signals of the brain, they were able to create sentences of their thought. So with this, what are our opportunities for India? The opportunities lie in integrating and creating convergence platforms. This digital convergence, whether it is transportation, healthcare, manufacturing, sustainable architectures, infrastructure, AI is the mechanism for creating convergence, because there you have a lot of data, You already have methods, and many of these methods can be used for very, very effective decision making. It is also something for social convergence. We developed a full program on end-to-end food sustainability, from production to market. And how do we use that whole data chain? We also used it for science and heritage interface. And we found that medical sciences has got the biggest signals, the best signals that we can do. And so using it for social convergence is another aspect. So this was our food sustainability architecture. It had got these 4 legs on supply chain, biotechnical solution, food production, and post-harvest technology, IIT Kharagpur being uniquely positioned to do that. Today, people are creating what are called urban observatories. And in the latest AI mission project, of which I am a part of with some other IITs, we have developed this architecture of urban observatory. You measure everything about an urban situation and try to come up with some integrated solutions. This is a model which we developed with our Coral, which was on trying to use our food sustainability and forest ecosystem on one side, river ecosystem on one side, ocean interaction and marine systems on one side, and coastal vulnerability on the other side, and integrating them to combine numerical models, statistical models, algorithms, machine learning, and data science into a very unique architecture. I have worked closely with ONGC, and ONGC there, this is a slide taken from some other place, but if you look at the whole of ONGC, they spend so much money doing their data analytics done by foreign companies, and now they are moving into their own mechanisms. So as you can see, everything from seismic analysis, reservoir models, all of them can be integrated into a single framework, and AI/ML offers a very, very unique opportunity for them. We developed this architecture, which we presented to the rural development for the government of India, where the regulation strategies, the interventions, the predictions, and the evaluation, where sustainable water and food, society, economy, and community practices were integrated. We ran a very interesting project of solar domes, where solar powered domes were used to generate electricity and light and charge batteries in very rural areas. And we are coming out with some very, very interesting results on the effect that it has had on education and things like that. If we think that AI/ML is only for technology, it is not. Whether it is the environment, protection of our mountains, rivers, structures, whether it is understanding or protecting languages like Achliki and others which have not been studied so far, whether it is trying to understand whether there is any music or mathematics or AI representation of our music, whether we can measure human health through meditation, yoga, whether new materials. We are also working with the tea, coffee, and the handloom industry. So AI is ubiquitous. AI does not need any particular area. Education, because many of us are in the education field, whether it is the content, whether it is the knowledge, whether it is assessment, whether it is delivery, whether it is interactions, whether it is analytics, AI, human AI interfaces, education, as you can see now, is going tremendous transformation. Faculty members are scared that students are using only AI to write their essays. Faculty members are using this AI to prepare question papers. They are not evaluating anything themselves. They are giving it to AI and getting some rubbish results. And this has become, because AI is faltering in many of these cases, AI is doing very well in some of these cases. You cannot make out a true from a fake. And therefore, this has become a big point of debate. And therefore, this is the joke that I want to. So the teacher is asking, oh, that to be or not to be a good boy, that was the question. So he says, I had an AI write my letter to Santa Claus in the style of Shakespeare. So I have been working with a lot of people to develop a new framework, because now education is completely different. We are trying to use a new framework called the spectrum framework, where it is not just a simple mechanism by which students are given lectures in the class. We are able to tell them to explore. We are able to tell them to enjoy. We are able to tell them to excel, and we are able to, make them happy about what they are doing. I won't go into too much of details, but at the school level, we are working with a large section of teachers and students to develop a framework by which we will try to give some prompting. So how to generate content? So here are some prompts. Can you provide compelling reasons supported by relevant examples and key statistics to illustrate the significance of studying X? This X can be replaced by anything in addressing, etc., etc. And it gives you the result. You just try to give ChatGPT say that I want to prepare a 1-hour lecture on the basics of thermodynamics to a class 12 student, giving an overview of the subject. It will give you the whole lecture structure. You ask it to prepare you a set of multiple choice questions with answer keys on a particular topic, and then you say, no, make it a little more difficult. You say, make it a little easier. All of it is able to do. So you can make it, we were doing very interesting things. We are saying in the area of relativity, can you create a joke which will do something like this? Can you create humorous anecdotes? And it produces results, but be careful that many of these results are not accurate. Because AI is still under, evolving. It is still not developed to perfection, and there are questions about it. So chatbots, media creators, there are lots of tools and markets. But let us come to potential boundaries and limitations. The first is AI is not a human being. And therefore, perception of AI, for example, this one, we know that those two horizontal lines are of the same dimension. But to our perception, initial perception, the bottom one appears shorter and the top one appears longer. But to AI, it will just measure. Look at this picture. We see not only one picture, we see two pictures, and it oscillates for us. So our own sensors and actuators create different perceptions than compared to what a machine will do. Look at this. The grandfather tells the grandson, when I was your age, I used to go to the market with 2 rupees and bring home soap, rice, milk, bread, ghee, face powder, etc. The grandson says, Dadu, nowadays it is difficult. There are CCTV cameras everywhere. So this is a joke. And why did we all laugh? Will AI laugh? Will AI be able to understand the emotional content of a joke? Today's AI, some of my friends are trying to understand sarcasm. But understanding humor is a very, very interesting problem for AI. Then you ask, can AI recreate Satyajit Ray, Rabindranath Tagore, or Hemant Kumar, or Ravi Shankar, Ali Akbar Khan? Don't be surprised that today they are producing music which sounds like Bach. They are producing paintings and fake, which is absolutely indiscernible. So there are these generative game playing AI techniques, which I did not go into, in which you can produce things which appear real to even an expert. The second is AI is Big Brother watching you. It affects your privacy. It has all information. And all of us know that if I write a text, if Professor writes a text to Professor Farooq, Professor Acharya writes a text to Professor Farooq Mistry asking for something on WhatsApp, you will see immediately on your Google, which is owned by a different company, you are getting ad recommendations of that same item. How come? Ad recommendations of the same item are coming up in that manner. So which means that this complete information, your everything of you is mapped. So, we had this Cambridge Analytica case in India a few days ago. The other is, this is an optical illusion for the human being. The left is two images are seen. On the right, though the blue lines are all straight, they appear to us as curved. AI does not see this as an illusion, but AI has its own optical illusions. That means, though a human being is seeing those two pictures as a pig, AI, with small variations, AI's decision boundary changes. And nowadays, with adversarial attacks, you can make AI take a decision on any direction that you want. And today's powerful adversarial AI is able to make AI take very, very wrong decisions. And you can make out that in several critical areas of medical or security or things like that, if you are able to attack AI, and then everything is gone. And believe me, the human being does not see this as different. But AI sees this as different because of the architecture of the neural network, the architecture of the AI, and the way in which you can tweak the decision boundaries. Therefore, having AI which is which does not have bias, data on AI, if you train it on the wrong data, for example, if you train it on the wrong data, we already found that there were so many places where training on the wrong data showed that even though people have the same qualification, the selection went to male rather than female because the number of people in the female category in the training data was low. So bias in the data, malice-induced AI or adversarial AI, hallucinations of AI are making AI a very, very difficult proposition to use. Therefore, we need interpretable models, explainable models of AI. AI has got legal impact. Today, when AI takes the decision, who is liable? So other than privacy, security, civil and criminal liability, personhood, when AI is taking a decision, is AI a person? Can AI own intellectual property? Australia has allowed AI to own intellectual property. So over a period of time, are you going to enable AI to have personhood? Are you going to have labor, contract, laws? So the future of learning, the future of work are all going to be dramatically affected by AI, and this is the area of deep research. Finally, bias, weaponization of AI, liability, and jobs are the biggest worries that society has today with AI. The most important things that we have with AI today is the following. People are actually using AI to make life comfortable for those who are already comfortable. AI is creating a digital divide. It is going to make the poorer countries poorer and the richer countries richer. And whatever was there in the digital divide, because knowledge is now at the crossroads, at the throes of people, unless we have open source democratized AI, we are going to get into deep trouble. Therefore, for India, we must follow Mahatma Gandhi, saying that if we want to bring about change using AI, we must find the people who need it the most. So harmonious AI is something that we are extremely required in India today. India needs to become powerful in AI, and like India, like everybody else and everywhere, India has been shown as the peacemaker of the world. India can become the peacemaker of the world, provided India takes up AI in an important and a very interesting way. Thank you very much. Sir, I have completed. If anybody questions are there, you asked me to speak up to 6, so I have spoken up to 6 o'clock. So any questions?
I request audience to raise the hand for the questions. Yes.
Professor Bhargav Bhattacharya has raised his
Yes,
hand. I think.
please.
Yeah, ABC, first of all, I want to thank you for your wonderful expository talk that spans over from the early days of AI to the modern perspectives. So just a comment, I mean, so as you see that AI has 4 stages from your lecture, which I can figure out that the initial stage was like, basically based on search and theorem proving kind of thing, formal sort of thing. And then second, it becomes knowledge based, a little bit knowledge based and kind of thing. Third is the learning based, and the final and fourth stage, which we are seeing now, is mostly based on LLM, large language models, and all kinds of application domains.
Correct.
So right. So regarding this power of AI, people are asking whether it can replace human being and so on. So see, it goes rise to the first question raised by Turing long ago, right? Can machines think? It's the same problem, right?
Yes.
So that Turing test has not, no machine has yet passed a Turing test, I guess. Is that so?
So what has happened is that the AI has bypassed the Turing test. AI has bypassed the Turing test. What it is doing is that it is not proving it that way. It is taking subject by subject, and for every topic, it is trying to make machinery, machine activities more powerful than human being. So today, language recognition, visual recognition, and several other tasks have surpassed human capability. What has not surpassed human capability is logical thinking, arithmetic and mathematical ability. It is far away from that yet. It makes silly mistakes. And it makes mistakes. And large language models, Professor Bhattacharya, will not solve that problem.
Right. Say, for example, in mathematics, we have a lot of unsolved conjectures. So if we give some of these problems to these AI-based tools, what would be the outcome? Those problems are unsolved for centuries.
Right. So it can. Let me give you what I'll give you one language which will tell you exactly what AI is doing. What if we understand that statement, which I have created, that statement of what AI is. Just give me a minute. I will come back to that. I will come to that slide. That my first slide where I drew those diagrams of AI. Yes. Yeah.
Yes.
So here I want to stress AI is probably approximately correct. So AI is never crisp. Modern AI is always probably approximately correct. So it says certain things with a certain degree of accuracy at a certain level of confidence. So now on each topic, we are moving with more accuracy and more confidence. But as we said, as you just pointed out, that in the area of will AI ever be able to come up with something like quantum mechanics? Will AI ever be able to come up with a theory of relativity? We are not yet sure.
Right. On the other hand, as far as the application domain are concerned, that's colossal.
Yes. Ordinary human beings are going to suffer a lot. If you are an
Right.
expert on a particular subject, you may get away with it, especially if you are an expert on a subject where there is less data. That means you know certain subjects for which there is less data, then you may still have some power. But in certain areas, it is going to become more. But it's going to, because of its enormous power and because of the way in which AI can be attacked, which even human beings cannot make out that AI can be attacked, it will start giving you wrong results and make you do something very, very peculiar.
Right. Okay. Thank you. Thanks, PVC, for your wonderful talk once again. I'm done.
Thank you. So I can see.
Anyone
I can
else?
see a few
I
questions.
find one.
Can I ask? I'm Sanat Kumar. Can I ask a question?
That's what I was
Sure,
thinking.
sir.
Okay. I am trying to say, for example, it may be a trivial question, but anyway, I am trying to use AI for troubleshooting. Let's
Yes,
say,
sir.
okay. Now, say it could be several things. Let's say a simple case in an automobile, car is not starting in the morning. Okay. So then, if I call a mechanic, he may give an answer. If I give the same problem to AI, it may give another answer. It may give a written answer. Now, my problem is, how do I know an answer given to me is by AI and not by a human? Let's say I prefer human answers as being more correct, because you also said it may be approximately correct. That's what you said. So does AI put a signature? I am AI so and so. I am giving you the answer.
No.
So then how do I know that a fellow? See, I go to some fellow and then he uses the AI and then gives me, say, this is what it is. Your carburetor is not right, or your fuel pump is not okay. But the AI is saying something else. No, you have to decarbonize your piston rings. Something like that it is telling. So which one do I take it to be correct? I have this problem. Just a minute. I have this problem in nuclear reactors. Very often, many things go wrong in nuclear reactors. So then I try to find out why it went wrong. Often enough, as an operator, I may not know exactly why it is. I asked something. So now, will AI tell me, no, you do some more experiments and tell me the answer? Because if I go to a regulator, he will tell, no, whatever you have given me, it is not okay. So you do some more experiments and tell me. That's what a regulator will tell me, human. But if AI, it says, will it tell? Now, this information is incomplete. You please do this more test and then give me the answer. Will it tell like this? These are two questions.
AI can tell, but today's AI does not tell you. But inherently in AI, it can tell. If it integrates search with its current large language models, there is a new technique called beam search. And then it can start saying that this is insufficient. As he said, it will say that the information is insufficient for me, and then it may ask you for more. So AI can do that, but many of the tools do not do that. Many of the tools just tell you something, which is not the right way to do AI. And therefore, I would always prescribe that use of modern AI, you must verify whatever AI says.
If there are two possible solutions for the same defect, will AI identify these two are the possible?
AI can find out.
These two are possible.
It can give the inherent mechanism of AI. It typically can give you the top X number of answers.
Okay, thank you very much.
Thank you.
Anybody else?
Professor Mistry had posted a question, and Suni Saab has posted a question. Can you repeat them?
I just, first of all, very excellent presentation. I just wanted to know, now they are saying that for every domain, there is a separate chat GPT. So chat grid has already come. And,
yes.
You kindly tell us something about that. Thank you so much.
Yeah. So in the whole of the grid, the what if situation, answering a what if situation, answering a risk situation, and answering whether the grid has been attacked or not, whether it has been a theft, whether it has been an attack on the grid, whether it is just a noise, then prediction of the grid, the failure of the grid, looking at all the components of the grid, They are trying to predict where it can go wrong. All of these are very interesting problems. The latest papers, Sunisab, that are coming out in the power grid sector, all of them are on making the grid stable, safe, taking safety critical decisions on the grid. All of them are there on the AI now.
Thank you.
Farooq, you wanted to ask?
My question to you, PPC, is the following. You've covered a lot of material, and by implication, you have indicated what AI means.
Right.
But that definition, I think, varies for the examples that you have given.
Correct.
I was wondering if you could share with us what is your definition of AI that would apply to what you've talked about.
The definition of AI is because AI tries. So one definition of AI, it is autonomous everything. One definition of AI is autonomous everything. Whether it is your thinking, whether it is acting, whether it is doing anything. So AI is all about autonomous everything. That is one way of looking at AI.
Autonomous what?
Everything. Autonomous everything.
But then
Anything
how
that you
does
want to
everything,
talk about?
how does everything tie to intelligence? We don't tell a human being or say about human intelligence that it's automation of everything. Why are we using the word AI to define automation of everything? Why not use AE?
No, that is because the word is evolved. AI was the term coined in 1965. It was coined in a conference where some of these people, Alan Newell, etc., were there, and they coined this term artificial intelligence. But the term has now come to embrace too many things. So people really are unable to pinpointedly define it because it crosses whatever it is to be defined. AI just is able to say the following. AI is trying to say that if you can define a problem, then AI should be able to solve the problem.
So it's not intelligence.
Whether intelligence is one aspect of it. Today, AI is trying to understand emotion. Today, AI is trying to understand action. Today, AI is trying to understand optimization. So everything is there. So if you take everything as part of intelligent behavior, then that is what it is.
Thank you.
I have a question.
Sir, I was waiting for your question.
No, firstly, I want to congratulate heavily Dr. PP, we call him, you remember Dr. PP in ISI, Calcutta and other places? We met.
Yes, sir.
Okay, now your lecture is so exemplary that I didn't find any area which is left out. The point here is that the diversity and the directions in which the current AI is going world over, we need many colleges or institutions to work on, not that we will get only benefit, but also to see what is the end story or end application or what is at the end. So even to know that, we have to do our research. I am really puzzled at the gamut of applications you have told. I'm sure it is only a subset of the total, but I think we need urgently some more institutions per se for AI. Thank you very much, and I congratulate you.
Thank you, sir. Thank you, sir. I was watching you. I was remembering all your X-rays and how today AI can use all the X-ray work that you had done.
Thank you.
Sir, Professor Soni sir has raised a hand.
Yeah, I've already answered his question.
Thank you, sir. Thank you.
So it is so nice to see so many of you here all of whom I respect so much. And I thank you so much for this enormous opportunity. And I'm grateful. I hope it was of some use. Each of these topics is worth a lecture of 3 hours. Each slide is worth a lecture of 3 hours. But I'm not capable of giving 3 hours on every slide. So whatever I have said is like AI, probably approximately correct.
No, what you said is correct. Today's our brain capability is only to absorb a little of that, because you said every
No,
slide.
sir, no, sir. This is a very interesting phenomena. The number of connections, the neurons and the connections in the brain are about 10 billion neurons and 100 trillion connections. But the number of all computers together in the world is still not reached 1/10 of that capacity.
Yeah, that is the reason. I mean, exactly. Okay.
That is another question. That cannot, the discussion of whether AI will surpass humans in everything or everything else, that cannot be done online. That Professor Acharya needs to organize a nice tea session on a round table for 5 hours for us to discuss that.
Anyway, Partha, this
Thank you,
lecture
sir.
was very, very interesting, illuminating, and for a fossil, it was.
But may I be allowed to ask one
useful
question? Sir, I have one question.
Sure,
Sir,
sure.
the question is that actually you have opened up the entire gallery of AI in front of us. So whenever we are going through any topic of AI, we are listening to many keywords, but practically you have shown the real visualization of AI, the entire gallery of AI. So as a teacher of AI, when we are teaching to the BTech undergraduate students or the master students, I'm talking from the syllabus point of view. Sir, only 25 to 30 hours lectures that we are completing the syllabus. Is it enough for our students to get prepared to tackle all the challenges of AI in the upcoming days, sir? Or how to progress?
No, teaching AI is like teaching swimming, madam.
Yes,
Throw them into the pool. Throw them into the pool.
Okay,
always
sir.
believe that, as Professor Acharya was trying to say, which I don't agree, that we are all fossils. We are, to them, their processing speed is faster. Everything else is faster than us. We only have to enable them. The only thing that we have to do is make sure they study according to scientific principles. Sometimes they study according to jargon principles. That is what we have to avoid.
Yes, sir. Yes, sir. That is true, sir. Because many of them are coping and they are also progressing at a very high speed. And those who are interested, they are tackling it up. But up to our satisfaction, what should be exactly the contents of syllabus, so that the students, we will be assured that yes, our Indian students also will be doing the wonderful events in the world, in the field of AI.
We are working in the Ministry of Education. We are trying to create a model syllabus structure. So we'll come up with that sometime very soon.
Okay, sir. Thank you, sir. Thank you.
Anybody else? I think
okay, sir. Thank you.
Hello is exhausted. Otherwise, many more questions would have come. Anyway.
I hope it was not boring for all of you, such a long lecture.
No, not at all. Nothing it was boring. Everything actually is very good. And you also earlier told that actually lecture will take 1.5 hours.
Yes, sir. Yes.
Okay. And plus, actually, we have another slot from you, again, depending on your convenience.
Sir, give me some time. It takes time to prepare a lecture like this. So.
Yeah, and it takes time. Now, one more question.
Sir.
This lecture is actually recorded. Do you have your permission to circulate?
Sure. Please.
Okay. Thank you so much. Now, Madam Renu.
Yes.
Please propose a vote of thanks.
Yes. Thanks.
Honorable Professor Damodar Acharya, Chairman, INE Bhubaneswar Chapter, Professor P.K. Nanda, Honorable Vice Chancellor, Shiksha Anusandhan deemed to be University, distinguished FNA, INE members, faculty members, and my dear participants, it is with profound gratitude and immense pleasure that I extend my heartfelt thanks to Professor Partha Chakrabarti, Department of Computer Science and Engineering, IIT Kharagpur, for gracing us with his insightful lecture on artificial intelligence, emerging phase of scientific, industrial, and social revolution, challenges and opportunity for India. On behalf of the organizing committee and all the attendees, it is my privilege and honor to extend our heartfelt gratitude to Professor Partha from the Department of CSE at Kharagpur for delivering such a provoking lecture on the burning topic. Professor Chakrabarti, your lecture has illuminated the profound impact that the artificial intelligence is having across various domains, from scientific advancement to industrial innovations and social transformation. Sir, your deep understanding and comprehensive overview of the subject have provided us with valuable perspective on how AI is reshaping our world and myriad of opportunities in the presence of the present India. Once again, thank you, Professor, for gracing us with your presence and sharing your expertise. We look forward for the future interactions and collaborations that will continue to advance our collective knowledge and capabilities in the realm of artificial intelligence. I would also like to express my gratitude to the organizers of this distinguished lecture, including INE Bhubaneswar Chapter, Shiksha Anusandhan deemed to be University, CSIR, MMT Bhubaneswar, NISER Bhubaneswar, and IEEE Bhubaneswar subsection. Their collaborative efforts in bringing together such a distinguished speaker and felicitating and giving us enriching session is really, really commendable. Thank you, sir. Jai Hind for devoting your time. Thank you, sir.
Thank you, Renu. One memento is due to him. Please send it. We give a short memento.
Yes, sir.
Okay. Thank you so much.
Thank you so much. Thank you. Namaste. Namaste.